Welcome back to some more geometry. Today, we are talking about parallel lines and transversals. Excuse me. All right, so let's kind of go into parallel lines themselves. So when we talk about parallel lines, we talk about two lines that never intersect. Hopefully, you probably have heard of parallel lines or discussed parallel lines before. So there are two lines that don't intersect. Now, we used to say that was the only it, but here's the thing: when we look at things in multiple surfaces, so then you create what's called skew lines. Skew lines technically don't intersect, but that doesn't mean they're parallel. So when we define parallel lines, we talk about coplanar lines. So they're all on the same surface. It's kind of like I can draw a line over here on the wall and then one on the ground. Will they ever intersect? Probably not, because this is on a wall and this is on the ground, and they'll never really touch the same spot. But are they parallel in the grand scheme of things? No. So can you draw parallel lines that run in the same manner on two different surfaces? Yeah, you can. But for the content of this right here, that's very rarely. We're talking about parallel lines on the same surface. So you exist on the same surface and you both are non-intersecting, so you go forever and ever in opposite direction and never touch, then you consider parallel lines. Now, lines that don't intersect, but they're on a different surface. So for example, kind of like this line is going through the plane, so it only touches the plane once right there, and this one exists on the plane. They never intersect because this is underneath the surface, so it's under the plane. Those we consider skew lines because they don't intersect, they don't touch at all, even at that one point. So they're called skew lines because they're non-coplanar, they're not on the same surface. All right, so now that we understand parallel lines, let's talk about angles. So these angles that we're going to talk about and the parts of the angles are specifically the name of the angles based off their location, okay, where they're at. When we talk about them with parallel lines, then they're going to have a deeper meaning than what they have right now. So let's kind of start with the basics right here. So when we have two lines running in opposite directions and we have a line that goes through them, so that intersects both of them to where it creates sets of angles, that's what we call transversal. The line itself right here, that's the transversal. It's the line that intersects the two other lines of the same surface. You get more than one line and they keep going, and it's still a transversal because it's just a transversal on three lines. So that's what transversals do. It's just a line, another line that intersects it and creates these angles. Now, the creation of the angles are very important. So let's talk about that. So we have what we call interior angles. So do interior in red. Yeah, red. Interior angles are angles on the inside. These two angles right here, everything on the inside is considered interior. So we have this right here on the inside as well. I have to kind of finish this because I don't like these little white specks right there. Perfect. This is all interior angles right here. This is all the interior of the shape. Okay, the exterior of this is all the outside. So everything on the outside is considered exterior. Everything exterior. They're outside the two intersected lines right there. Okay, so we have the interior angles, the inside angles right here, angle 3, angle 4, angle 6, angle 5, those are all interior. And then we have the exterior angles, the ones on the outside, angle 1, angle 2, and angle 7 and angle 8. Those are our exterior angles. Now, when we talk about consecutive interior angles, this kind of break down the word consecutive. Now, if you heard the word consecutive, you know it means different things, but one after the other one next to the other one, or the one that comes after, directly after. So consecutive means just that, one after the other one. And then we're looking at interior angles. So looking at angle 3 right here, what angle is consecutive to angle 3? So it comes right after it with nothing interrupting it, okay? It'll be angle 5 because what makes them consecutive is they have to be on the same side of the transversal. So angle 3 and angle 5, they're consecutive interior angles to each other. And then angle 4 and angle 6, they're consecutive interior angles to each other. So these are each other's little partners, inside partners. These are each other's little partners on here. They're adjacent angles. So remember, we just use the word adjacent next to, but there is that interruption of the transversal right there. So these two angles right here, of course, are consecutive. So that's positioning. Those are the types of angles. Now we're going to refer back to these interior and exterior when we speak on these next three angles. So let's talk about the next three angles. So these next angles right here, alternate interior angles. Let's break that apart. Alternate meaning opposite, a different style on the other kind. When we look at football teams, they do alternate jerseys, so they're kind of opposite of the color scheme they usually wear, but relatively close to it. So that's what an opposite or alternate is. So when we talk about alternate interior angles, we'll do that in there. We're talking about inside angles, so we got 4 options. We got 4 inside angles, and we're going to speak on alternate of each other. So they're going to be non-adjacent, so they can't be right next to each other as far as adjacentness, and they're on the opposite side of the transversal. So those are the key parts right here. Let me re-underline that. Non-adjacent, opposite of the transversal. So for example, angle 3. Okay, so it can't be adjacent, so it can't be 4, and it has to be opposite the transversal, so it can't be 5. So the only option is 6 right here. These 2 angles are alternate interior to each other, right? And then angle 4 right here is alternate interior to 5. So those are each other's alternate interior partners, buddies, best friends, or whatever you want to call them. Now let's look at alternate exterior angles. Same idea, same thought. So angle 1, alternate exterior buddy, is angle 8 down here. Somebody kind of said they kind of look like they're almost like vertical in a sense, and you can kind of see how they kind of are, like they're across from each other, but it's just a big gap in between. They're kind of like jumping the river right here, or jumping a little stream. Angle 7 right here is alternate exterior to angle 2. They're each other's friend. Now, before we move on, what did we call 2 angles that are across from each other? Do you remember that? Those are vertical angles. Remember, 2 and 3, those are vertical angles. Vertical angles. And then 1 and 4 are vertical angles. 5 and 8 are vertical angles, and 7 and 6 are vertical angles. So hopefully you remember that, because what did we say about vertical angles? They are congruent, and they still are. Regardless of how the angle is shaped, the lines intersection, these are still forever will always be congruent to each other, because you have 2 lines intersected and the angles across from each other. Now the last one right here we're going to talk about is corresponding angles. Corresponding angles. They're angles. So look at the word corresponding. So when I think of the word corresponding, I always think of the news anchors. News anchors are people that do this. They report on the news. So sometimes you have news anchors in studios, and sometimes you have corresponding news anchors that are on location. They're called corresponding anchors because they're doing the same job. They're reporting the news. They just happen to be on site versus in studio. So corresponding angles are angles that are in the same position as itself, just in a different group of angles or on a different line. So for example, angle 1 up here is a top left angle. What other angle is also a top left angle in a different position? That would be this angle 5. These 2 angles are corresponding to each other because they're in the same position, relatively in the same position as each other, just in a different group. So angle 2 right here is corresponding to angle 6. And then, of course, angle 7 is to 3. And hopefully you can assume the last one, 4 is to 8. These are corresponding angles. They're relatively in the same position as each other, just in a different group. Now, when we start talking about parallel lines and these angles, we're going to see something a little more unique about these type of angles. But let's kind of test your knowledge on what we just talked about. So go ahead and pause for a second and then determine what type of angle relation are these angles to each other. So 5 to 15, 11 to 17, and so on and so forth. All right. So hopefully you went through it all and checked. So 5, let's look at 5. 5 and 15. So this is a group of angles we're talking about, and this is a group of angles. So making C right here, the transversal. If you hopefully pay attention, they're alternate exterior angles to each other. Alternate exterior angles. Good job. Let's look at 11 right here and 17. Ooh. So this is a group of angles, this group of angles, so that means B right here is transversal. These are the 2 angles that are being intersected. So in this case, they're on the same side of the transversal, and they're both interior angles. So if you remember, that's our consecutive interior angles. All right. Let's look at 13 right here, 13 and 8 right there. So this is the group of angles. This is the group of angles making this the transversal. If you can see, they're both interior angles, but they're opposite of the transversal. So they're alternate interior angles. alternate interior angles. Let's look at 14 right here and 6 up here, relatively in the same position as each other, just on a different group. That's our corresponding angles. And then we got 1, then green, 1 up here and 10 right here. So this one kind of looks a little odd, but here's a group of angles. Here's a group of angles. Is transversal. They're opposite the transversal, and they're exterior angles in the grand scheme of things. So they're alternate exterior angles. So hopefully you got that right there, and that makes sense to you. All right, let's go ahead and move on to the second half of this. All right, so now we're going to look at these specific angles strictly with parallel lines. So these postulates and these theorems always say if two lines are cut by transversal. So we're talking about two parallel lines for sure. So we can go ahead and assume, hey, these two lines are parallel. Now the way they mark parallel in the books is either they put a single little arrow like that. They have the same arrow, so that means these two are parallel to each other. Or they have a more solid triangle arrow looking type of thing right there. So they'll have it solid. They'll only have one or the other. They won't have both. So but they'll have something like this. Say, hey, these two lines are parallel. Like, all right, I know they're parallel. So because these lines are parallel, then we can go ahead and assume that the corresponding angles are congruent. That's important now. So now angle 1 and angle 3, they're congruent to each other. Angle 7 and angle 5, they're congruent to each other. 4 over here and 2 over here, they're congruent to each other. And then, of course, 8 and 6, they're congruent to each other. So that's what we come about this. So, hey, 5 and 3 are still congruent because they're vertical angles. 1 and 7 are still congruent. But then now, as well as corresponding angles, they're congruent to each other as well. All right. The next one right here, still talking about parallel lines. So we got our parallel lines. Bam, 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 bam. And now we're talking about the alternate interior angles. The alternate interior angles are also congruent. So angle 1 and angle 3, they're alternate interior. So if you were to spin this whole thing around and flip it, 3 and 1 will be in each other's position still, because that's what corresponding angles, alternate interior angles do. They're in each other's position, just on a different kind of group or a different style, different method. We're going to turn upside down. And 2 and 4, of course, are also congruent. Remember, if we forgot, congruent means the same, our little symbol. So they have the same value. They have the same measurement. They have the same look in the sense, kind of like how wide each other is. And of course, if we look at it, kind of using common sense, 1 is a small angle, very relative. 4 is a big angle right here, much bigger than 90 degrees. So we know those are not the same. So this kind of follows the same pattern because of the intersection. These two small angles have the same measurement, and then these two right here have the same measurement. So, and in the same manner, alternate exterior also are congruent. So angle 1 way out here and angle 3 way over here are congruent to each other. And of course, angle 2 and angle 4, they're congruent to each other. Oh, but this is the last one. So overall, we talked about 3 main types of angles. We talked about corresponding, alternate interior, alternate exterior, and consecutive. So all 3 of these prior to this one are all congruent. But this consecutive interior angle is a little bit different. Let's look at that. So we got 2 lines that are parallel, and they're cut by transversal. So the same side or the consecutive interior angles are supplementary. Do you remember what supplementary means? Hopefully we do. It means they equal 180 together. So angle 1 right here and angle 2. So I say, hey, angle 1 plus angle 2, that equals 180. And then same thing with these 2 over here. Angle 4 plus angle 3. They equal 180 as well because they're on the same side of the transversal. It's almost like having a rectangle. Like on a rectangle, 90 and 90. Now, we talk about opposite sides on the rectangle, how they are congruent, but one thing we haven't talked about is that they're also parallel. These lines are parallel right here, these 2 long ones, and so are the 2 side ones, the 2 small ones. But if we look at these 2 long ones right here, I'm going to change color so we know this. Treated kind of like hey, there's 2 lines that continue on, and then the side can be treated like a transversal. You see we have 2 90s, they equal 90 on this side, and they also equal 90 on the other side. 180, sorry. 180 and 180. So it's no different. So this same idea also works with shapes when it comes time to deal with other shapes as well. All right, so those are the 3 unique ones that we always talk about. We talk about alternate interior angles, alternate exterior angles, and this is the abbreviations you can use when you do like a 2-column proofs. Corresponding angles, and of course, are consecutive interior angles. These 4 types of angles are going to be the majority of things you're going to be dealing with in your work today. All right, our last little theorem right here that we're going to speak on is it's called the perpendicular transitive theorem. The name of the theorem is longer than the actual representation of what's talking about. It's saying that if I have 2 lines that are parallel for sure, and I got one right angle, then the other one's also right angle. And not just that one, they're all right angle, all 8 of them. So that's all this theorem is saying. It's nothing that deep, but it does let you go ahead and say, let's say they number this 1 and 2, and then you didn't have this little box, they just had that one box right there, but you do know the lines are congruent or parallel, then you can make the assumption, oh, well, angle 1 is 90, so then angle 2 is also 90 by the perpendicular transitive theorem. Not very often we use that one very much. But referring back to the 4 things that we talked about, this is how you kind of see some of the assignments right here. So you got, excuse me, angle 7 is 125. So this angle right here is 125. Right there. I do know that X and Y are parallel to each other. FYI, this little double line right there, that's the symbol for saying that the lines are parallel. And then NQ are parallel to each other. So you see how they have a single arrow right here? That's how they usually mark them. The single arrows are parallel to each other, and the double arrows are parallel to each other. Kind of like the arcs, the single arcs are congruent to each other, and the double arcs are congruent to each other. So take a second, and I want you to tell me the relationship these angles have to angle 7, and then what's the measurement. So that's the whole theorem supporting your answer type of thing. So angle 15, if you look at this, 7 and 15, they're corresponding to each other, corresponding angles. And since they're corresponding, they are congruent, meaning it's the same value. Angle 1 is not from this section, but a previous one. That is vertical. It's a vertical angle. Vertical angle, so it's the same as well, 125. Angle 3 over here, they're alternate interior angles. So they are also congruent. And angle 5 over here, they're also corresponding to each other. So it's another corresponding angles, and they are also congruent. But angle 6, ooh, it's a little bit different. If you look at the angle, it's definitely smaller than 7. If you remember, these 2 are consecutive interior angles. And if you remember consecutive interior angles, they're supplementary. And that means to find angle 6, we'll take 180 minus the 125, and we get 55. All right, y'all. Hopefully that helps, and I'll see you another day.